So tomorrow is your final exam. Okay, tomorrow is your final exam. Here is the breakdown of it. It's 20 questions. They're multiple choice or multi-select. Okay, so those are the two different types of questions that you might see. There's 13 questions that come from linear and quadratic functions. Now, remember, this is a test that we don't get to see prior to. All we get to do is see kind of like an outline of the different AKS they're going to pull from. Okay, so this is kind of the breakdown. You've got 13 questions coming from linear and quadratic, and then 2 are coming from rewriting radical to rational exponents and simplifying, and then 5 are going to come from linear inequalities, writing them, and also solving them. Okay, so that's where that's coming from. Your final exam review guide has been structured so that it kind of represents this. Again, we gave you our best guess at what the final exam was going to look like. However, we don't always know. Okay, so all right. On this first one, it says identify the slope and the y-intercept. This is key features. This is going to be in that 13 question section potentially. The first thing we want to do is we want to write this in y equals mx plus b form. I'm going to rearrange this. I'm going to move the 3x to the other side. And so that's going to give me negative 5y equals negative 3x plus 10. So I move the 3x by subtracting it. I'm going to divide by negative 5. And so that's going to give me y equals, this will make positive 3/5 x plus 10 divided by negative 5 is negative 2. So what's the slope? Well, the slope is this 3/5. And then here's my y-intercept. On the next one, it's asking for rate of change. Rate of change is just a fancy way of saying slope. If you don't know the formula for slope, here it is. I don't know if they'll actually give this to you. I don't remember if this is actually on the formula sheet or not. At this point, you should have this one memorized. But you're 0 to 4. That's what this is saying, from 0 to 4. So 0 is going to be my x1, and 4 is going to be my x2. And then we're going to look at what is the y value. Well, when x is 0, my y is 2. So that's going to be my y1. And then when x is 4, my y2 is going to be 46. So now I'm going to substitute in 46 minus 2 over 4 minus 0. So that's going to give me 44 divided by 4, which is going to give me 11. There will be a rate of change question on this final. Like I'm telling you right now, they always ask one. Okay, it may look like this, or it may say, here's an equation, find the rate of change. It's asking for rate of change, but it's giving you a graph. So we're going to go from negative 2 to 2. So from negative 2 to 2. Okay, now we can do this either visually or we can actually do it with the equation. I'm going to use the equation just to keep it simple. But when x is 2, my y was 1. And when x is negative 2, my y was 3. You always want to start with whatever they give you first. So that's my x1, and then that's my x2. So x1, y1, and x2, y2. Notice how I label everything before I plug it in. When I plug it in, I'm going to get 1 minus 3 over 2 minus negative 2, which that will make that positive on the bottom. 1 minus 3 is negative 2. 2 plus 2 is going to give me 4. And I can simplify this down to negative 1/2. Another way we could see this is if we go down 2 and over 4. So it's rise over run, right? Number 4. There's definitely going to be a question about domain. They always ask a question about domain. All right, so a local theater sells admission tickets for $9 on Thursday nights. At capacity, the theater holds 100 customers. Here's the function. It represents the amount of money the theater takes in on Thursday nights, where in is the number of customers. What is the domain and range of this in context? Okay. So this is the amount of money that they make. So it's $9 per ticket. So what does N represent? Number of tickets, right? All right, how many tickets could you possibly have? What if nobody shows up? How many tickets were sold? 0. And how much do they potentially have? Up to 100, right? They can only hold 100 people. Now, if you sold 0 tickets, how much money are you making? 0. If you sold 100 tickets, how much money are you going to make? Okay, does everybody see how I did that? I said, what's my domain? What does it represent in context? What's the lowest amount I could possibly have? What's the highest amount I could possibly have? On number 5, it's asking for the slope and y-intercept. Well, this is already in that y equals mx plus b form. So what's my slope? Well, slope is 2, and my y-intercept is -7. Okay, on this one, what is my y-intercept? Okay, so when x is 0, that's my y-intercept, right? But they don't have it listed here. So what's the difference between these numbers? 5. Are we going up by 5? Yeah. Okay. So if I wanted to know when x was 0, what am I going to do from -5? Subtract. What's -5 minus 5? So my y-intercept is -10. Number 7. So to rent a carpet cleaner at the hardware store, there is a set fee and an hourly rate. The rental cost, C, can be determined using this equation when the carpet cleaner is rented for H hours. Determine the initial fee and the hourly rate. Okay, so how much do we start with? What's my y-intercept? 25. So the initial fee is 25. That's my y-intercept. How much is it per hour? 3. So it's $3 per hour. Number 8 is that next section, and it's talking about inequalities. Now remember, you're going to have Desmos, so make sure that you utilize that. So we're going to take this, we're going to graph it in Desmos, and then draw a sketch. Thanks. Okay, so this is what it looks like. I would draw a sketch of this. Remember, our solution is going to be where it's both shaded over. Okay, so in this purple region, we need to pick a solution. So we could pick 5, 5. That's a solution. If you pick something in just the red or just the blue, that's not a solution. It has to work for both. A non-solution would be something like 0, 0. Notice how it's not in a shaded region. Okay. I don't know what number 8 is. Okay, go ahead and see. We've been working on factoring. Go ahead and see if you can factor this one. Remember, that's the big X with the box and all that jazz. Checking to make sure that you got this going on right. First term goes in the first box. Last term goes in the last box. A times C is -180. B is -8. Now, I don't know those factors off the top of my head. So if I go into Desmos and I type 180 divided by X, and I look at the table, Well, I can see that I have 10 and 18 that I could add together to get -8, right? So that would be -18 and 10. So I'm gonna plug those in. And then I'm gonna say what times what would give me this. Again, you kind of have to play around with these. You get a little bit better at it after a while. But 2x times 3x would give me 6x squared. What times 3x would give me -18x? -6. And then what times 2x would give me 10x? It's 5. On a lot of y'all's mastery checks, y'all got majority of this stuff right, except for this like last box, and that threw you off. You need to make sure that you check this box too. -6 times 5 should be -30, and it is. So this is 2x minus 6 times 3x plus 5. Now, they could have asked for you to completely factor this out, but instead they asked us to find the roots. So that means that we're going to take both of these, set them equal to 0, and solve. And so that means that I'm going to get 3 on this one and -5/3 on this one. Okay. This one asks us to complete the square. Remember, when we complete the square, we're going to move our C term. Well, first we're going to divide everything by 2 and then move our C term. But another way you could have done this without having to like actually solve anything is you're going to take this and plug it into Desmos. And then you can find the minimum. So it's right there. It's -5. Now we could have done this the long way. We could have completed the square. That would look like this. But this is a lot of effort, and we're not here for that. So again, plug this in. It tells you what your y value is. Now on the next one, we're trying to figure out which one is the ordered pair of this minimum. Okay. Again, we could take this and we can plug it into Desmos and look for the minimum. And that's going to be -3, -4. On 17, a ball is thrown straight up from the top of 128-foot tall building with an initial speed of 32 feet per second. Lord. Okay. How long will it take for the ball to hit the ground? A lot of y'all struggled with this on your test. So let's graph it and then talk about it. So when we go in here, we're going to type it in. So how long does it take before it hits the ground? So from here to here is what we're asking, right? So from 0 to 4, so how many seconds does it take until it hits the ground? 4 seconds. Now, when is the ball's height increasing? So when is it going up? Well, let's look. Well, it starts from 0, because remember, we can't have negative time, so it's not back here. We go from 0, and it's going up. And we need to look at what's the maximum. Maximum is 1. From 0 to 1 is when it's increasing. And then it starts coming back down. So we're going to say from 0 to 1. Again, this is going to come from those 13 questions about quadratics. You're going to have something like this, and it's going to be some type of word problem. So now it's asking, when is the ball's height decreasing? Well, that's from 1 to 4. So it's literally like the rest of the time that it's in the air, right? Does this function have a maximum or minimum? So look at our y values. We go -1, -2, back up to -1, back up to +2. So we went -1 down to -2, back up to -1, and then up to 2. So does it have a max or a min? A minimum. And what is the minimum? Well, that's 2, -2. Hypothetically say, what if you got a 0 on the final exam? That would drop your grade 15 points. That does not mean that if you get 100, it'll bring it up 15 points. That's not how that works. Okay. So it depends on what you have in the class. Okay. I don't know. All right. Which function represents the sequence? Okay. So on here, what is it going up by each time? What is it going up by each time? 6, right? Okay. What does it start with initially? 1. Okay. So when we plug in 1, we should get 2. When we plug in 2, we should get 8. Let's try it. If we plug 1 in here, we get 2. But if we plug in 2, do we get 8? No. Looking at the next one, when we plug in 1, do we get 2? No. On the next one, if I plug in 1, do I get 2? Yes, that is true. If I plug in 2, do I get 8? No. On the last one, if I plug in 1 into this equation, do I get 2? Yes. If I plug in 2, do I get 8? Yes. So D should be your answer. Okay, so what we did was we just kind of like plugged in and checked it. This one, I think I'll mess up the most. Watch what happens. I'm going to show you a shortcut, and you don't even have to know any math for this. If I take 2 square root of 8, and I multiply it times 2 square root of 20. If I go into Desmos, and I type this in, look at what the decimal is. So what I'm going to do is I'm going to take my options, and I'm going to plug those in, and then see which ones are the same. So if I took 2 square root of 28, are those the same decimals? No. What about 8 square root of 10? Are those the same decimals? No. Yes. But I didn't even have to do any math, and I found the answer. On this next one, it says a computer store is placing an order for computers and tablets. Each computer costs that much, blah, 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 right? On these, they give you the inequality, so you don't have to write them. However, it says, which combination of computers and tablets can the computer store order? I would highly suggest when you have something like this, what you do is you take this and you plug it into Desmos and then see where those two things cross over, or see where these points would lie. So if I come in here, and I type these in, then what I can do is I can take each one of these points and then I'm going to plot those and see which one lies in those like dark shaded region. So which one actually lies in the purple region? That's 8, 4. Okay.